Well, wasn't that fun? There's all sorts of things that you could be doing with these flat dice. And if you take a look at the PDF that's attached to this file, or you'll see the link somewhere around here, go to that PDF, go grab it. It's got some details about the effect, the history of the effect, some thoughts and ideas that I had when I put all this stuff together, and the work I had to do to make the math work out, don't ask. All of my labor of love just for you. But it also reflects back to the origins of this effect, which comes from a George Sand's idea that he published in the New Phoenix magazine. It was July of 1954, and you'll see the reference with the volume number right over there, right about, right there. Yeah, cool. I can go like this because we'll superimpose it in later in the after production. So let's take a look and discuss a bit more about this effect. So in the original George Sand's idea, he described it essentially as a bar trick. And as a bar, you would basically take a napkin, right, paper napkin, and tear it into 4 pieces and take out a pen. And you'd put the numbers 1 on one side and put 2 on another side, and then 3 and 4. And we'd go 5, 6, and 7, and 8. And he would take these pieces of paper and give them to his volunteer spectator, and he would say, mix these up, and then throw them up in the air, Happy New Year, and flip them over any way that you want, and using a similar type of a mathematical formula, performed basically the same stuff that we're doing with flat dice. And I thought, this is really cool. There's some really interesting things you can do with that. But I didn't like the flimsiness of using pieces of paper or a napkin or even tearing up a business card. This just reeks of mathematics when you do it this way. And I wanted something that was going to be a bit more mysterious. In doing so, I thought of taking an object which is pretty common to us all, and that's dice, right? And if you were going to do it with dice, though, you'd have to create something that gives you the capability of these little pieces of paper. By capability, flat, one number on one side and another number on the other side. And you can get that if you've got basically 2-dimensional dice. Well, you can't have 2 dimensions, but you can have dice that are much, much thinner than the standard die. So this is set up the same way, except instead of numbers 1 through 8, we really have numbers 1 through 6. So one die has 1 on this side, and it's got 2 on the other side. And then another one has 3 and 4 on the other side, and 5 and 6. Again, very similar to the 1, 2, 3, 4, 5. And we don't go up to 8, though. It's really just 1 through 6 is what we have over here. Now, to use the George Sand's math, you would need a next die to have the numbers 7 and 8 on it. And originally I played around with that, but that looked, using a die with 7 pips on one side and 8 on the other looked pretty cool. But you know what? At one point, it was really tough to read, and you couldn't add these up fast because it's something that you just don't see in real life. So I thought, what if we had 2 sets of flat dice? So it's 2 sets of the 1 through 6. So again, that's what we have here. We've got 1 and 2 on this one, 3 and 4, and 5 and 6 on this one. And then the math, I was able to play around with the mathematical formula a little bit to get this thing to work. What if then you take, instead of 6, you did 9 dice, or you did more? And I found out that this formula that I devised works for 3 dice, 6 dice, 9 dice, and even beyond that. So let's talk a little bit about the mathematical formula, and it's really a very, very easy thing. You just have to remember 1 or 2 simple things. So if 6 dice are used, for example. The formula is whatever the number of flat dice are in use. You start with that number in your formula. So here it's 6. You ask the spectator to ask them how many of the faces that are face up are odd number faces. And they count. There's 1, 2, 3 odd faces that are face up. So you take the number of flat dice, and from that you subtract the number of odd-faced dice. It's 3. And you take the total that you get there is 3, right? 6 minus 3 is 3. And you add that number, that total, that 3, to a constant value for 6 dice, which is the number 18. So 6 minus 3 odd sides face up equals 3, and you take that number 3 and add it to 18, and you get, math geniuses out there, what do you get? You get 21. And that's the total of the flat dice over here. So let's total them up together. And the way I like to do this quickly is I group things into groups of 6. Number 6, so, number 10. So I have 6 and 4 is 10, and I have 5 and 3 is 8, and 2 more make 10, so I'm grouping them in 10s, and I've got 1 left. So it's 10, and 10 equals 20, plus 1 is 21. And that's what we had come up with. That's what we just said, because when we did that mathematical formula. So let's do it again. Right, shake it up this time, and let them roll. And you can offer up again to the spectators. They can take any 1 or 2 or 3 or all of them, and they can re-roll them. They can flip a few around, and after they're done doing all the flipping and the rolling, you say to them, okay, do you have a distribution of numbers in front of you that's like a good distribution of numbers? And do you have like a good distribution of odds and evens in front of you as well? For example, how many of the dice that you're seeing have odd faces that are showing? And they'll count them. 1, 2, 3. So again, you do the math. 6 minus 3 equals 3. 3 plus the constant, 18, equals 21. So again, even though there's different numbers here that are showing, the total here is 21. Again, I try to put things in terms of numbers of 10. So here's 6 and 2 and 2. So there's a 10 over there. And can't do it over here, but you can do 5 and 6 is 11. 11 plus 10 is 21, just like before. Get it? It's easy, isn't it? We had a total 21 both times. Let's do this one more time, see if we get a different total over here. And how many flat dice, how many odds do we have showing? And in this case, we still have 3 showing. So we'll take these 2 odds and we'll shake them up. And now we have, oh good, so now we have 1, we've got 2 odd faces showing. So now do the math. 6 minus 2 equals, right, 4. And 4 plus 18, the constant, 4 plus 18 equals 22. Very good. Let's count them. So we have 6 and 4 is 10. And we have, let's look at it this way. We've got 10 and 9 and 1. So there's another 10 over here, equals 20. And 2 is 22, just like we said. 6 flat dice minus 2 equals 4. Constant is 18. 18 plus 4 equals 22. And there we have the total of 22. Now, again, pay close attention to the wording when you do this. The spectator will take the flat dice. You're going to turn your head away at this point, or turn the whole body away at this point, and tell her to give it a really good shake and let them fly to the table so she can easily see all the faces of the dice that are showing. And then say, are you happy with the roll that you have? Do you want to pick up any one die or 2 or 3 or all of them and re-roll them or turn them over or flip them around in any way, shape, or form? Do that now until you're happy with the numbers that you were seeing. And usually Sometimes they'll do, like at max, one more roll to pick up half of the dice, or two or three, tops, and do one more roll. Most of the time they'll say, no, this is okay, because they're not really sure what you're talking about, because these are so unusual to look at. But that's fine. That's cool. So now you say to her, and you have a nice distribution of numbers that you're looking at now. Well, they don't know what a good distribution versus not a good distribution is. So again, they're usually going to say yes. And you continue on. So you have a nice mix of odds and evens that you are seeing. Yes. Now you ask the question. So with the odds and evens, for example, how many odd faces do you see? And pause way we say it. Do it that way. How many odd faces do you see? Because you're saying, as an example, you want the question to appear to be inconsequential, but of course it's very consequential because it gives you the answer that you need. So how many odd faces do you see? Count up the odd faces. 1, 2. I got 2 odd faces. Then think of another question. Or again, and the odd faces, so you got 2 odd faces, and again, you think that that's a good mix and a good distribution with all the others. Or are the dice all over the table, or are they kind of put together? Think of any other question that you can ask at that point. As soon as you get the answer of the number of odd faces, that psychologically will deflect from them giving you that bit of information that you need. So she has just told you there's 2 odd faces, and right away, instantly, you know that the answer is going to be 22. Why? 6 flat dice in the first phase. You know you've got 2 odd faces. 2 minus 6 equals 4. 18, your constant, plus 4 equals 22. So what I say at this point is total the dice. Make sure you have that number of the total firmly in your mind. Don't forget it. Create a picture of a movie screen, and that number, the total, keeps appearing on the movie screen over and over and over again. So think of that number. Think to yourself, my number is 22. My number is 22. My number is 22. And as you say it 3 times, you turn around and look at them, because they will have gotten the joke. And they will also have been amazed at the same time that you were able to read her mind, because her number is 22. Pretty cool, huh? So you say at this point, this was a tough thing to do with 6 flat dice. I'm going to make it even more difficult now by adding 3 more flat dice to the mix. And you drop the next set of 3 flat dice on the table. Now these are the same. Again, it's 1 and 2, and 3 and 4, and 5 and 6. And the rules for the formula are the same, basically the same as they are with 6 flat dice, except the constant value changes. Instead of being 18, it's now 27, 27. So the formula is the same as before. You take the number of flat dice that are in play, and now there's 9 flat dice in play. Have them give you the total of odd faces showing. Subtract that number from 9, the total number of flat dice in play, and whatever the result is, whatever that total is at that point, the result, you add that number to the constant. The constant is now 27, and that'll give you the number that they're thinking of. So it's the same thing. You have her take the dice and give it a really good shake, drop it to the table. She can pick up any 1 or 2 dice, and at times, depending on how this is moving along and how interactive your spectators want to get, I'll say to another spectator, give me a number from 1 to 9, and they'll, whatever number they say, they'll say 5. And you go to the dice thrower spectator and say, now pick up 5 dice and re-roll them, or play it any way that you want. The key is you want them to know that the roll of the dice is absolutely totally random, and you want to keep calling them dice. You want to keep referring to them as dice. They look like dice, so they're going to think that they could be rolling 6 numbers, when in actuality they can only roll 2 numbers on each of the dice, and that's dice, and that's partly how the math works. So let's take a look down here, and let's take a look at the way the numbers work out. So again, do you have a nice mixture of odds and evens on the table? For example, how many odd faces do you see face up at this point? Take the odds and separate them from the evens, which isn't a thing you probably ought to do when you're dealing with the 9 dice, because that way you'll get a more accurate count, and it's a little easier for them to count. And how many odd faces do you see face up at this point? 1, 2, 3, 4, 5. So you remember again, you're turned away this whole time, and you have a piece of paper and a pen that you are holding at this point. And what you are going to do is you're going to write down the number that's over here that you come up with on the die, and you're going to take it, and after they total up the dice as before, you come and you put the piece of paper on the table, and you help them re-add everything. And after they do that, that's when you show the number. So again, over here, how many odd faces do you have showing up now? You've got 5. So 9 minus 5 equals 4. And you take 4 and add it to 27, and you get 31. So again, you're turned around, you're not facing them. How many face-up dice do you see? And they'll say 5, and then as soon as you hear that, again, you know the answer. I mean, that second later, it's pretty easy to do this math. Second later, you take the pen and you scribble in big numbers, 31, as you see here. And when you turn around, I usually like to take the prediction and put it in the clip of the pen, and I just put it down on the table and point to it and say, I'm committed to this. This is here. I am not going to touch this. Let's take a look together and let's total the dice together. So then again, you might want to use the adding it up via tens, like I try to do to make it easier. So there's 1 10, 5 and 5 is 10, and there's 5 and there's another 10. So 10 and 10 is 20. And let's see, we've got another 5. And we have 4, so that equals 9. So it's 10, 20, and 9 is 29, 30, and 31. So 2 is 30 and 31. We've got a total of 31. Is that correct? Is that correct? And you ask all the spectators if that is indeed what the number is. And again, stress, they took the dice, they shook them up, they threw them to the table. They had a chance to roll them and re-roll them and re-roll them a third time. And all they did is they looked at it, they totaled the number of dice, and you committed by putting what the information that you were able to read their minds on this piece of paper. The total is 31. You open this up, and of course it says 31, and everybody will be happy, and they'll cheer you and throw money at you. Well, hopefully they'll throw. Who cares about the cheers, right? Just throw money. No applause, please. Just throw money. So this is a very, very strong effect. And it's a cool effect. People will really like it. They'll like the themes behind it. They'll love playing around with these. They'll look at these. They'll see if there's some way these dice could be signaling you. And that's why I wanted these 3D printed so that they're transparent, so that you can see that this it's just pieces of plastic. And they've got all sorts of manufacturing little bits in here and stuff. I mean, there's nothing in there. It's clearly the way it is. So it could only be mind reading. So again, what you've done in the questions that you've asked them in an innocent fashion. You're hiding the real true question that you need. How many odds are face up? It just seems inconsequential when you ask. Again, do you have a nice distribution of dice on the table? Yes. Do you have a nice distribution of odds and evens? Or do you have a nice distribution of dice? Separate the odds from the evens. Move the odds to one side and the evens to the other. It's just going to be easy to total the dice at the end. So you want to keep referring to the total of the dice, because that's their ultimate goal. Get them to think about it. And as you're doing that, they'll psychologically actually start to add some of the stuff in their minds, forgetting about other things that you say and do, which is great misdirection, psychological misdirection for you, right? So, do you have a good distribution of odds and evens? For example, how many odd dice faces do you see at this time? 5. and you've been able to separate them and you're happy that these are the numbers that you want. Again, as soon as they tell you the number of odd faces, you ask another question. It could be any question at all. It doesn't even have to do with this effect. Just ask them another question to get them thinking about something else quickly, because they will know at some point they're going to have to do math. Oh my God, they're going to have to add this stuff up. But again, as soon as you know what the number of odd faces, you know what the answer for the total is going to be. And again, it's I've got 5 odd faces. 9 total of flat dice minus 5 is equal to 4, and 4 plus 27, which is the constant for 9, equals 31. And then that tells us exactly what we need, and you write it on the paper and you put this down here and you let this sit for a moment. You basically ignore this when this is down here and go over here and help them add it up and say that's the way it is, that's the way. Remember, you had a choice of doing all this stuff. You did, it was your free will, your free choice. You know, the only possible way I can get an indication of this is to basically read your mind. And that's what I did, because in my mind I totaled up what I saw and came up with 31. So those are the first 2 phases, and it's essentially the same thing, except you're using 6 pieces, 6 flat dice in the first phase, and then making it more difficult in the second phase by adding 3 more into all this. And now we move to the final phase. Now there are multiple things that you can do in the final phase, and this is the one that you saw on the demo, and this was the original one that I came up with. So first of all, let me just show you an interesting mathematical feature on all of this, and then you can see how and why and the reason for this working. If you take the 9 flat dice and you have them randomly put on the table, and then you arrange them so only odd faces show. So let me flip a few of these over. Only odd faces are showing over here, right? And then you say to the spectators, now take any one of the dice and flip it over on the other side. So we see an even number showing, and they flip this one over. And again, they shook the dice, they rolled out the random contents of the dice, and then they turned one over. That's how you phrase it. But here's the interesting thing. If you take the dice and arrange them so that they're all odds face up, and they turn one over, when you count the total, you get, let's do it together. So there's 10, and there's 20, 26, 27, and 28. So again, all odds face up, you turn it over so that only one even faces up, you get 28. Here's the cool thing. It doesn't matter which die is turned over. When it's all odds face up, they can turn over any flat die, and the total will always be 28. So when they say yo odd and they set it up so all odds are face up and they turn it over so that one even shows up, you will always get a 28, always. And the reverse is true with a different number. They yell yo even, so now you have all evens turn face up. You tell them to turn all evens face up and take any one of the flat dice and turn it around so that an odd number shows. It doesn't matter which odd number shows, right? The total is always the same. It's always 35. Always 35. So they take the flat dice for the big finale. They give it a big shake. Whoops, one fell. Give it a big shake, drop it to the table, and they've yelled yo even, for example. So they take the dice and they put them so that only even numbers show. Only even numbers show. And then you say take any one of the flat dice and turn it over so an odd number shows. And they turn that one over. As soon as they say yo even or yo odd, you know what the total is going to be. It's either going to be 35 or 28. Right? So basically what I have here is an envelope that is a two-way out envelope. It is 2 little envelopes, little pay envelopes that you can make at home. Little envelopes, and I glued them so that they're back to back or rather address side to address side. The flaps are over here. So I got one flap opening here and one flap opening here on the other side. Sort of like a little Z envelope. Can you see that okay? And in one side of the envelope, in very small print, let me see if you can see that. Yeah, maybe. It says 35. And on this flap, on the other side, it says 28. So I have a picture, the one that you saw, of a regulation die with a 3 and a 5. So if the total comes up and the answer is 35, you put this down, and I predicted that. I had this picture ahead of time. And the pattern that I used is 35. That's such a cool number. When I was 35 years old, I went to Vegas. I gambled $35, turned it into $35,000. I was really lucky. And my winning roll that night happened to be 35, 35, which is the total that you have here. I even took a picture of it that night. And in fact, I knew you were going to roll that number. That's why I left this picture on the table the whole time. And again, you left this on the table from the beginning. It's been sitting here, and you take it and you open up a little packet. I left this on the table the whole time, and you open up and you reach in and pull a picture out, and there it is, and you show 30, 35 over there. If they roll 28, if this totals 28, and that happens when all the dice are all odds and they turn one over so that an even shows, again, you would flip the packet over so that the little number over here says 28, and you know this is the side, because you will see in your kit that you got with this, when you purchase flat dice, there's a second picture in here of a dice formation that's 28, 2, 8. And people laugh when they see it. It might take them a second to get the joke, because they know that no die totals has 8 spots on it. So it is kind of funny. It's an impossible looking object. Some of my friends say that you should ditch the 35 possibility and equivoke to take you always to 28, and that would be your finale. This idea comes from John Bannon, and John said it's such a weird looking thing, and it really caps off the routine in a nice way, that this is something, just have a little envelope that with a big question mark on it that you can put down at the beginning, leave it there, don't mention it, don't talk about it, just leave it sitting there until you get to the very end, and then show it. So how do you do this equivoke at the end? Again, you have them shake up the dice, and as they're shaking up the dice, you point to them and you say, odds or evens. And whatever they say, it doesn't matter what they say, because when you have this, you want to have them immediately shake out the dice and turn them all so that they're odd faces up. And then you say, what did you say in the beginning, odds or evens? You said evens, so take one of the dice and turn it around so you see an even number. So that's how you work the equivoke. Now, if they say odds, say, okay, fine, take all the dice that you shook out and make sure only odd numbers show. So, and again, the other way around is if they say evens, you say, okay, well, take the dice. First, we're going to turn them all so odd numbers are face up, and then take any one of them and turn it so that the even number shows. So that's the way you equivoke it. And you'll always end up with the total that's going to total 28 on this thing, 2-8. So that's the overall routine for flat dice. And I mentioned there are a few other things that you can do with this. So in the original George Sands piece in The New Phoenix, he talked about doing a book test, which it's kind of getting away from the point of the theme that you use, because it's kind of a disconnect, but maybe you have a gambling book with you. You have John Scarney on dice, perhaps. What you need to do is to memorize the first words on page 28 and the first words on page 35. So whatever they throw at the end, you say, okay, that's totals 35. Now turn to page 35 and look at the first few words on there. And then you do the mind reading thing and you read their minds. Or turn to page 28 and you can do it that way as well. Now, another cool way to end this, and this is a way that I've been ending this effect for some time now, because it ties in very nicely, is when you get to the finale, you take the deck of cards out of your pocket. Now remember, in the beginning you're talking about how all gamblers, you know, they have their lucky deck of cards and they have their lucky dice. I got something new, I got flat dice. Remember that from the beginning. So now you go to this, and you do want to go through this equivoke situation to have them get to the point where they are rolling all the odd numbers, and you have them flip over one and it's an even number. So you want to get it to a number 28, right? And then you say, oh, you know what, that's really interesting. Take out the deck of cards that's sitting right there in front of us the whole time. Remember I said it was my lucky deck. Take it out, open it up, and turn it face up, and deal 28 cards. Deal down to the 28th card. Just put them in a pile right here. So it's 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 24, 25, 26, 27, 28. So they deal down to the Jack of Diamonds over here. And you say, that's my lucky deck of cards, and Jack of Diamonds is absolutely positively my lucky card. And not only is it my lucky card that you were able to get to from the lucky roll of my lucky flat dice, but it's not only my lucky card, but it's the only red card in this deck of blue cards. So that's a very satisfying conclusion to all of this, because it ties everything together. Your lucky cards, your lucky dice. It's the only red card in a deck of blue cards, so that's very a good way of wrapping it up. If it's somebody's birthday and you're doing the trick for the birthday, so instead of doing the card over there, take a blank card, right? It's somebody's birthday, and you write "Happy Birthday, Jane." Happy birthday, Marilyn. Happy birthday, Seth. Or, you know, what a lucky person you are, Marilyn. What a lucky person. You put some type of personalized message on this card, and you put the blank card in the 28th position. And again, as before, you have them, you know, that random number, and you have them deal down. Oh, look at that. You know, it's got a really nice message. Now, here's a really cool thing to do. If you're doing this thing where they're going to be dealing down, if you have a stacked deck, first of all, if you've got 28 cards to go through, so you've got a little less than half of the deck that you can stack. If you know you don't require too many stacked cards on top, you can just keep them there. Or you can take the 28 cards, say you've got a whole memorized deck over here, and you don't want to screw up the order of the bottom cards. What you do is you take the 27 cards in the bottom, and you put them in reverse order. Count them off in reverse order, place the Jack down, and place these on top, right? So now the spectator takes them and counts them. And in the process of them counting out to the 28th card, what they're doing is they are reversing the order of the cards that you have reversed the order from earlier. They put them back in order. In other words, reversing the reverse order puts them back in order. You do the bit with the Jack. Look, it's red. All the other cards are blue. You take these, you put them right back on top, and your stacked deck, your memorized deck, is back in the appropriate order. And you can put these cards away, set them aside as you do your cleanup over here. Look at that, it's really nice, red, blah, blah, blah. Isn't that cool? And you can move on from there. So those are a few ideas. A friend who does a lot of close-up work also told me one of the things he would like to do is to take the regulation casino dice, and during the course of all this, get them in his left hand. And then he would pick up 2 flat dice, put them in sort of a finger palm in the right hand, and do a false transfer of these dice into his other hand, where he has the regular casino dice. So you're taking the flats, you're putting them in here, where the flats are still there, but you got the regular casino dice in here. And then he would take this and put it to his mouth, like he's blowing it up, right? Inflating it, and let the regulation size dice fall out, like he took the flat dice and inflated them to regular size dice again. And then he would go into some type of an effect using regulation casino dice. Finally, you can, if you have a type of a switch box, or a devil's handkerchief or something where you can affect some kind of a switch, you can have, you can take, I don't know, 6 regular size red dice and put them in there, and you can take a bunch of the bunch of the flat dice at the end and dump them in the devil's handkerchief and make them disappear and switch them out for the regulation dice. There's all sorts of things that you can do at that point. And again, there's a tremendous number of effects that you can use with these flat dice themselves, and even the formula that because anytime you want to force a number, if the number is 28 or 35, it's a surefire way of getting, you do this routine, you end up with either a 28 or a 35, then you go into the next routine where you needed the forced number. So that's a pretty cool segue into all of that. You will have a lot of fun with this, coming up with lots of ideas. Oh, one more quick thing I want to touch on. Here we are at the end. I'm talking about something at the beginning. You have a little bag to carry the flat dice in. So when you have them, you want to put all 9 of the dice in. Hold back. You're able to hold. You can feel the dice in the bag. Hold back 3 dice. So you're only dumping 6 out to start with. And then you go through the routine with the 6 dice, and then you say, now we're going to make it even harder. Reach back to the bag, and let the other 3 drop to the table at that point, and then you can continue on with the routine. So that's it. I would love to see what else you can come up with, other ideas that you come up with using the flat dice or the mathematical formula for flat dice. In any case, have a great time with it. See ya.